Okay, so today I'm going to show how angle, angle, angle is not true on the plane for determining if two triangles are congruent. And to start, I'm going to form my first triangle right here, triangle ABC. And then I'm going to measure these angles since I will need to use them later in showing that it's not true. Last angle here. Okay, then I'm going to create another triangle with the same exact angle values but different size, so basically a similar triangle, but that is showing that just because they have the same angle values, they're not congruent triangles. So to do that, I am going to use the dilate tool. Oops. Click all of them. Transform, dilate. Yes. So there's a triangle, and this is just a small version of triangle ABC. But to make it easier to see, I'm gonna copy this triangle and paste it right over here. Oops, I don't want these points though. Hide those points. Okay, so here's this triangle, which is the same as this one right here, which is just a smaller version of triangle ABC. So to show you guys that, I am going to measure the angles of this triangle, and they should be exactly the same. And the last one. And there you go. And as you can see, every single angle matches, but triangle FD prime E prime is not the same as triangle ABC. Even though they have the exact angle values the same, they are not congruent triangles by their size. But they are similar triangles, but that's different. The questions that I would like to answer is technology differs in this lesson plan because many times when you ask students if angle, angle, angle is true on the plane, they right away say yes, especially since it normally comes after side, 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 where that is true. But this is much better for them to see it out rather than visualizing it in their head because it's shown here. And I would use this as a teacher definitely for angle, 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 but I think it would be better for all the other rules like side, side angle, and etc. because the students can construct it on their own and play around and move the triangles, and then that will be so much easier in determining if the rule is true or not, rather than just trying to figure it out by drawing on their paper a bunch of different scenarios of triangles and seeing if it's true. I would ask the students before I created the other similar triangle down here if they thought that it was true or not, and I think most students say it is, and on here it's so much easier to see that it's not a valid form of determining if the two triangles are congruent. I would definitely ask the students to use GSP to construct or replicate this, obviously, so they can really understand by doing it themselves why it's not valid. And then I would then go from there and asking them for detailed explanations of why is it not valid. So obviously it's a really helpful tool, not even in angle, but for all the rules. And then the content knowledge, I definitely think this helps them in learning that I want them to realize that angle is not a correct rule for learning for determining if two triangles are congruent. And from this, for future students, I hope that they will want to investigate the other rules, since, like I mentioned earlier, this is a really, really great tool in learning this. It's because when I was learning just on paper, it's really not you don't get the same grasps as easily as you could on here by being able to move them and not just doing it with a static lesson plan on a paper. And then the other thing that I want the future students to learn and be interested in is how to write the proofs up for these, because obviously when you learn this, you're learning on how to do proofs. And that's it.